Hello, Midnight Coders, and welcome to another episode of The Midnight Coder. Today, we've made a fundamental architectural change. We are moving away from session-based authentication in favor of JWT authentication. Now, this is not a refactor for the sake of refactoring. This is a shift in how the application thinks about trust. So, make sure you've got that full cup of coffee, and let's dive on in. Most developers start out with session-based because they're simple, familiar, and Spring makes it almost invisible. But as soon as you start to think about scalability, APIs, microservices, or even front-end separation, sessions start to work against you. So to understand why JWT exists, we need to understand what problem sessions actually create. So what is a session? A session-based system is stateful. So after a user logs in, the server creates a session. The session is stored server-side. The client receives a session identifier, usually in the form of a cookie. And then every request sends that ID back to the server. So the server then asks, do I recognize this ID? Is it still valid? This means that the server must remember who the user is. And the server owns the authentication state. So this seems nice at first. It's easy to implement, secure by default, and it's very well integrated into Spring Security. For monolithic applications, this is perfectly fine. The only hidden cost of sessions is not security. The hidden problem is state. State creates coupling. You cannot easily scale horizontally. You must share session storage across instances. Load balancers must be session aware. And APIs become tightly bound to infrastructure. And when we try to scale this, it turns into sticky sessions, Redis clusters, serialization issues, debugging nightmares, and the server becomes responsible for remembering everyone. And that doesn't really scale well. So stateless authentication was the fix. Stateless systems flip the responsibility. So instead of the server remembering the user, the client actually provides who they are on every request. Now that might sound dangerous at first, until you realize how cryptography changes the game for that. In a stateless system, the server does not store authentication state. Every request is self-contained, and the server verifies, not remembers. So this is where JWT comes in. What is JWT? A JWT is a JSON web token, also commonly pronounced as a JWT. Now, a JWT is compact, signed piece of data. It is issued by the server, and it's stored by the client, and it's sent with every request. It contains who the user is, what their roles are, as well as when the token itself expires. And most importantly, it is cryptographically signed. The server does not trust the client. The server trusts the signature. So if the signature is valid, then the token was issued by us so that the data has not been tampered with. Therefore, the request can be authenticated. There's no session lookups, there's no shared states, and there is no memory of past requests. So why were JWT even introduced? JWT exists because web applications stopped being monolithic. APIs became first-class citizens, and infrastructure became distributed. That makes JWTs ideal for REST APIs, microservices, front-end and back-end separation, as well as horizontal scaling and cloud-native deployments. JWT aligns with how the modern web actually works. But now, what are the trade-offs? There's always trade-offs. Now, JWTs are not magic. You trade easy server-side invalidation for stateless scalability, to which you must then think about token expiration, refresh tokens, revocation strategies, and storage on the client side. But these are explicit trade-offs, not a hidden complexity. Sessions optimize for convenience. JWT optimizes for architecture. So as systems grow, stateless beats stateful, verification beats memory, and predictability beats magic. Therefore, JWT forces you to be more intentional, um, and intentional design scales. Okay, so enough of that ramble. What does this actually look like? How do we go about implementing all that jabber? So, let's take a look. Now that we understand why JWT was introduced and the problem that it solves, let's dive a little deeper and crawl into our igloo. Here, we added the use of a JWT authentication filter, as well as we have changed up our session management to be that of stateless. Down here, we added a filter we added the filter before so that we could stick our JWT filter before our username and password authentication filter. In here, we are extending once per request filter. A once per request filter is a Spring Web filter base class that guarantees a given filter executes only once per HTTP request, even in the presence of internal forwards, includes, and/or asynchronous dispatches. It's commonly used for cross-cutting concerns such as JWT authentication. where the logic must run exactly once per request lifecycle rather than once per servlet dispatch. We start out by extracting the cookie from the header. We then validate that the token is not blank and that our security context is null, because that tells us that the user is not authenticated and that we must set the authentication. We then call out to our JWT service to ask if the token is indeed valid. Towards then, if it is, we extract the claims. We then fetch the principal from the claims, which is just the subject or who the JWT is issued for. We then also build out the authorities that this user is supposed to have, or the roles that this user has. And then we create a username password authentication token, which we then set into our security context. Finally, once complete, we continue down the security chain. Here, we are building out the JWT information. We provide the issuer, the audience, the time to live in minutes for the JWT, as well as the clock skew in seconds, and of course the secret that we use to create a unique signature. And if you're not too sure what a clock skew is, if you are working with, or if you're working across different servers, all of their clocks may not necessarily be in sync. Clock skew is like a little buffer for this case that allows both devices to validate the token. So it's kind of like a little bit of a cushion, like you can be offset by so much. So if the secret itself is blank, we throw an issue. Otherwise, we generate a signature from the raw secret. We start out by encoding the secret with, make that a little bigger. We start out by encoding the secret with base 64. Then we do a quick digest of type SHA-256, SHA-256. Once we've generated the token, we then go ahead and assign claims to it. So here is where we assign the user's roles to the claims. We also build out the identity, who it is. So we also stick in their authorities, what they're allowed to do, as well as the other contexts, such as the issuer, the audience, and the dates of expiration and signing. So we also have a validation method where we assert that the claims of the token are not null. We also have a way to parse the claims so that the auth service can handle each of them. Finally, we have a way to extract the roles from the JWT that it claims to hold. So now, when a user submits their credentials, the server then authenticates the user, issues the JWT, for which it also caches a refresh token to the database. And the client then stores the token, and subsequent requests include said JWT. So now, what is a refresh token? I would like to start out by stating that this is how I learned refresh tokens back in the day. And that this may not be the ideal setup that most people use. This is just what I learned back in the day, we'll say. So we start out when the user logs in. We build up our refresh token service, which we set up the refresh time to live days. So this is 14 days. We set up if we are detecting reuse, if we are revoking the whole family on reuse, as well as if we are cleaning up any expired, followed by a cleanup grace period. And a user logs in, we issue a new refresh token. First, we start out and revoke any existing tokens, and then we build out our new refresh token. We start out by setting up the time of right now. When it expires, we generate a raw token. We then hash the raw token, and we build out the new refresh token. We set up the UUID, the email, the token hash, the issued at, expiries. We set up the user agent and the IP of the person that this token is built for. We cache it to memory, and we return a DTO. We then have a method of returning an optional, make that bigger so we can see it. We also have a method of returning an optional of an active token. We provide the raw token, and it returns us a DTO of a valid active token. We also have a way to rotate said token. We can take in a token that we want to rotate. If it is not revoked, we then check to see if the user is looking to if we are looking to do reuses. And if we are, we log it, and then we check if we're revoking the family um, on revocation. I always struggle with that word. Otherwise, if the token is expired, then we simply set up the time that we revoked it, we cache it, and we return the result of expired. Otherwise, if the token is not expired, we can just issue a new refresh token um, and link it to the family of tokens. We also have ways to remove a specific token or an entire family. This is why we want to have short-lived JWTs. so that if we need to revoke somebody's token, we can easily do this with the, um, sorry, we cannot easily do this with JWT like we would with sessions. By having a way to expire or revoke a refresh token and its family, we force the user to re-log in once their JWT has expired. So keeping JWTs short-lived and using refresh tokens for longevity, making sure to store refresh tokens, ideally the hashed version, into a database for revocation. Revocation. I always struggle with that word. Um, Avoiding to putting any sensitive information into a JWT. You never want to put sensitive information into a JWT. Never put a password. Never put a secret. JWTs can be decrypted and read. Your secret cannot be, but the payload and the contents can be. So you have to be careful with that. Handling logos. You have to make sure that you invalidate refresh tokens as well as clearing cookies. If you take one thing away from this video, let it be this. JWT is not about being fancy or modern. It's about systems that scale, stay stateless, and behave predictably. If you're a junior developer that's trying to grow past the just making it work, and you want to understand more about why we moved away from session-based to JWT, this is a big step forward. Now, in our next videos, we're going to keep breaking down more real-world decisions. So if you've made it this far, thank you very much for watching. I hope you've learned something. Hit that like button if you did. If you'd like to learn more, remember to hit that subscribe button, turn on the notifications so that way you get notified once I go live or when I post the next episode. As always, keep your curiosity open, your skills sharp, and that coffee cup full. I'll catch you in the next one.